Hi everybody, how's it going? This is Samir again from Stockholm Microsoldering and Board Repair. Today I've got a MacBook, a 13-inch MacBook Air from the middle of 2012, Core i7, model number A1466. The problem with this MacBook is that the power button doesn't turn the computer on. Even that the keyboard is working fine and everything works fine, everything works just fine except for the power button that doesn't turn the computer on. The customer says in order to turn the computer on, he has to hook the charger to turn the computer on, and as we all know, all the older model numbers of the MacBooks, as soon as you hook the charger, they turn themselves on. So before we proceed on the repair of this issue, I'm gonna go through all the symptoms because you might probably have the similar problem and make this video useful and share some tips with you. And then we're gonna see if there is something wrong with the keyboard, the opposite of what the customer says, or is it some physical damage on the power button itself, or is it simply a board problem that has to do with the SMC chip. The SMC chip is the chip responsible for taking the signal from the power button to turn the computer on. So let's get started with this repair and see what's wrong with this little MacBook and see if eventually we can fix the problem. So after checking the board, I have seen that the SMC capacitor and resistor that doesn't exist on the schematic that says omit, which means that they don't exist on the board, and I have seen that there is nothing wrong with the board. Before proceeding either reflowing or revolving the SMC chip, I need to do an SMC reset. How to do the SMC reset? We're gonna click on Alt, Control, Shift, Control, Alt and Power at the same time. Nothing happens. Just give it some time. And since the power button it's not working, because resetting the SMC solves a lot of problems like the power button, the keyboard, the fan. The SMC means System Management Controller, and it reset also the current going through the board. So I'm gonna do it one more time. I'm gonna click power. I'm gonna hook the charger at the same time while I will click while I will push Shift, Control, Alt. I can do this with two hands, so I'm gonna click Shift, Control, Alt and connect the charger and click on the power button at the same time. I'm gonna keep clicking like this for a while. Maybe it restarts. Let's see how it's gonna behave. So if this solution doesn't work, then we're gonna need to reflow first the SMC, and then we're gonna remove it and reball it. So I'm gonna do the same check again on the keyboard. And check if it's working. So as you see, this button is not working. Otherwise all the buttons are working. And we check the keyboard. So except these 2 points that doesn't work. The button besides works. Button on the left side works. Everything works. I'm gonna click the power button again. It doesn't work. Shut off the computer and start with an SMC repair. So the first thing I see here that this MacBook is missing some screws. Now first we're gonna start taking the back cover. There are a lot of screws missing. I have here only 1, 2, 3 screws, which indicate that this MacBook, someone has been working on it before. Okay, even the screws, the head of the screws are damaged, which will make it difficult to remove the back cover. But anyway, that's how it is. What are you gonna do? So I have, as I said, I have only 3 screws on this MacBook here, and one of the screw is completely damaged, which indicates that this MacBook has been on some repair table before. Yeah, so this is the back side. Wow, what I see here. Okay. What I see here. I should make you a picture on the microscope actually. I should show you this on the microscope. Now I see that there are like jumpers with 2 lines, and there are like this wire, 2 wires coming out or going out, trying to create an external button. I'm going to show you this external button here. Wow, it's going out here. Look at this. An external button. 2 wires. They tried to make 2 wires from the capacitor that is responsible for starting the machine, and they made the jumper with these 2 wires here. You see, these 2 wires, and they took them out. They made a hole on the edges on the frame. Yeah, but then maybe there was a temporary solution. So let's try if this solution worked. I'm gonna try to start the computer from these 2 wires here. Gonna grab a metal thing. Yeah, it seems that it's working. Yeah, you see? It worked. So that seems like a temporary solution, because they couldn't fix the board. They couldn't figure out what's the problem with the board, so they made a jumper from the capacitor that is responsible for making a short and giving the signal to the SMC to start the machine. They made this jumper that I'm going to show you on the microscope. How does it look like? On the microscope, these are the 2 points that creates the external button. Actually, this external button works just fine. So the question is, let me just zoom in here. The question is if there should be a component there, or are they just test points that connects short the SMC to ground so that the machine will start. Board. This is the charger. This is where the charger is connected. This is the keyboard connector, and this is where the jumpers or the wires are made. So if you look at this, what this resistor, it says resistor as I said. If we look at this resistor, it says SMC on off, and it's resistor R5015. Let's look at the resistor R5015 on the schematic. R5015. and it says debug power button, SMC on off. So this resistor is missing. If there was no resistor there, as you see, let me make you a picture here. So we have a resistor missing here. We have a resistor missing on this place, and if it wasn't missing, so it would say on the schematic no stuff. So I assume that this resistor is missing. There should be a resistor here to make the SMC start. Okay, so let's so before we start removing these wires, we're gonna just make a small inspection on this area here. Since the board is working, as the computer is fully working, and we don't see any corrosion, any liquid damage on the board, so we don't need to give it that much time looking for something abnormal. The board looks just fine for me. This is the fuse for the backlight, looks fine, looks just fine for me, beautiful and nice, no problem. No liquid damage on the board. Let's make another inspection here on this area and see if we have something. This is the sticker that indicates if the board was water damaged or not. As you see, the sticker looks just fine, so this board wasn't touched by water at all. And yeah, so this is the place where they were working on, and yeah, these are the 2 points connecting the external button. Oh, look at this here, look at the keyboard connector, look at the keyboard flex cable here. That doesn't look so good. That doesn't look so good. So what can we see about this? What can we say? Yeah, so this, replacing the keyboard and grabbing this keyboard connector flex cable with a bad way could result in breaking this line here. Let's see on the board view what this line is about. The line is number, what number is this line? Let me show you this on what number is this line? 1, 2, 3, 4, 5. This is the broken line. I assume that this line is broken. I see some traces here, and we're gonna check it out. We're gonna figure out if this line is not connected. So 1, 2, 3, 4, 5. Line number 5. Let's look on line number 5 on the board view. Line number 5 on the board view. Line number 5, 1, 2, 3, 4, 5. What does it say? PP T-pod. T-pod. It's connected to the keyboard. T-pod filter. This gives 5 volt. And it's actually from here. It starts from here. From 1, it's pin 10. And pin 9 is SMC bus. SMC bus. Yeah, it's an SMC SM bus 3. Okay, so this line here doesn't look good for me. We're gonna check it out and we're gonna see if it looks okay. So the first thing I'm gonna start with before replacing this component, as I said, according to my experience, there should be a resistor there. As it says on the schematic here, there should be a resistor. SMC on off, resistor 5015. 5015, and this is 5015 SMC on off, and that makes the external button. Okay, is the resistor missing, or is it just test point? If it's just test point and the resistor is not missing, it should say no stuff. It should say no stuff on the schematics. Let's see if the schematic says no stuff. The schematic doesn't say no stuff here. Debug power button, SMC reset button, supervisor, and AVREF supply. Okay, let's take a look at this. If we see this, the number of the pins, we don't see the number of the pins. Okay, that's fine, we don't need to care about all this. SMC on off. So we assume that resistor 5015 is missing, and the keyboard connector, the keyboard flex cable, doesn't look nice for me. So what I'm going to start to do here, I'm going to start some scraping, and I'm going to do some test point. I'm going to test this line here if it makes some continuity. I'm going to make some scraping until I get to the copper. Scrape. If we don't get some continuity, then we know that the problem is already solved. But if we don't get some continuity, then we will understand that there is something wrong with the resistor. No. My probes are beeping when I touch them together. I don't get any continuity. Didn't I scrape correctly? I'm gonna push there, push keyboard, and make this repair expensive. We want to repair it with less cost. Now I see the copper. I'm gonna take my probes. My multimeter is in continuity mode, as you see. One probes here. Now I'm 100% there. I touch the copper here. I get some continuity. So this line is working just fine. Okay. So the line is working just fine. Next is to remove these wires and get resistor there. We're gonna get resistor there. We have disconnected the battery, of course. So we're gonna get rid of all these wires and get resistor. We'll get new resistor there. My kiosk gear, my best friend, is working just perfect. It's nice. It beeps and it says I'm ready. Put some flex. Just a little bit of flex. Don't need that much flex. Much flex makes the board dirty. Let me zoom in. I'm going to remove these two wires. So the first wire is gone, second wire is gone. Okay, let's clean it a little bit more. Yes, nice. So now let's get this board a new resistor and see if we're going to solve the problem. So what I have noticed here, that all the schematics shows that the omit resistors doesn't exist. So what I'm gonna do here, I'm gonna measure this resistor here, capacitor 5734, and let's look on it on the schematics. Capacitor, where is it again? Capacitor 5734, 5734, 5734. Let's put capacitor there. Let's look on it. Let's look for it there. And I should get 2.5 volt. If I don't get 2.5 volt, or I get a value, then there is nothing wrong with the capacitor. So what I'm gonna do, I'm gonna hook my charger here to start the MacBook. Just gonna remove some screws here that are connected to the magnet. I see the green light. I should get 2.5, alright? So let's measure this capacitor here, and it's down, and I get 3.4. 3.426, it's almost 3.5, which means the capacitor is not short to the ground, and it's working just as it should, but it's reading high value. So before I start reflowing or reballing the SMC, because reballing the SMC is very, very difficult thing to do, because the balls doesn't stick to the chip, and resoldering it to the board is the most challenges thing. I'm gonna unplug the charger, and I'm gonna put this board back and reset the SMC before reflowing the SMC again. So on my donor board I don't even find even the other resistor, and it says omit, which means that it doesn't exist. So on my donor board, which is 2915, and let's look on resistor. Let's look for resistor 1560. Okay, on the 2915 board. 2915 board. And we're gonna look on resistor. Yeah, oh, it's 1560. Yeah, and it says it's in here. Did I flip the board? Yes, I should flip the board to save. So this is my donor board. And this is my donor board. Let me get it here on the screen. Come on. Okay. Just be here, okay, alright? So this is my donor board, and this is the resistor that I'm looking for, and it's located up here next to this connector. Let me zoom on the board view. So we see the connector here, this is another connector, and the resistor is in here. resistor should be here. So since it says on the schematics omit, so this resistor doesn't exist, and I am pretty sure that this donor board, I haven't removed any resistor from it. So let's keep looking on where we can find the same resistor. Or we're gonna do like this. We're gonna go back to our board, which is 3209, 3209, where is it? It's this one here, and we're gonna look on the other resistor, which is 5016, that says omit, and we're gonna look if this resistor is in the board, is on the board also. Yeah, 5016. Yeah, it's in there. Here is it. Let's look on the microscope if this resistor is in there. Oh my god, it should be on the other side of the board. It should be on the other side of the board. Then I have to remove the board. Yes. I have to remove the board. I have to take out the board. But let's assume that we don't have a similar donor board. Then we are going to need to grab this resistor from another donor board. How we're going to do it? We're going to read the values of this particular resistor. Here it says resistor 5015. I'm going to grab pen and paper. I'm going to write resistor 5015 with 5% resistance, and these values we just remember them by heart. This is say 1/10V. 603 is the size. 603 is the size, but we don't care about the size. So we're going to take another donor board and we're going to check if we're going to similar resistor. I think I'm almost done. I'm trying to check if there is some underfill under. I don't think so, because I feel the pads. I feel the pads. So I'm gonna change my temperature to 500. I'm going to check these two components here, how wet. Look at this. What the hell? Are they up, or I just see them up, or what happened? What's happening here? No, they're fine. They're fine. Okay. And see how Apple designs its machines. They don't even put on the MacBook, they don't even put the edges of the chip where you're gonna put it. Is it like here and here and here and here? There should be like some streak some dash or some lines, white lines here, to see where the edges of the chip. But anyway, it doesn't matter. So let's put some flux on the chip here and try to reflow it using 500 degrees. Just give it some flux. But don't inhale this shit. I'm just trying not to put so much flux. Just enough so that it will go beneath the chip and helps the parts to flow. Okay. Now I'm going with 500 degrees. .40 airflow. Just reflow it. If it dances or if it moves, that's gonna be a big day. If it doesn't, means that the underfill is still hindering it from flowing. Can you heat it one more time? A little bit more. Trying to move it, it's not moving. It's not moving. Actually, it doesn't matter if it moves or not. Yes, no. Now it's moving a little bit. I think there is still some underfill under the chip. So while reflowing it, I'm just gonna click on it a little bit. From all edges, all sides. Try not to make the balls coming out. Yes, 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 yes. It's moving now, it's moving, now it's moving. Now it's moving, now it's moving. Dance, baby, dance, 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 dance. Dance, dance, dance. Dance for me. Sit, 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 sit. From the other side also a little bit. Yes. Okay. Let the board just cool down and let's see if our problem will be solved. So now I have assembled the board again as quick as possible, and here is the moment of truth. Now we're going to open the computer and we're going to hit the power button and see if the SMC chip was reset. The lights turn orange, which means that the battery is uncharged even if we hit the power button, so the battery will not turn, the computer will not turn on because the battery is uncharged. And even if we have fixed the problem, hitting the power button will not make the MacBook starting or turning on.